What if I told you that the entire universe, the grand cosmic ocean in which our world is just a tiny, shimmering island, is being shaped by just such a force? Tonight we embark on an extraordinary journey, not to a distant star or a newly discovered planet, but into the vast, silent emptiness between them. We are going to explore the most profound mystery in all of science, a silent, invisible force that constitutes nearly 70% of everything that exists, a phantom presence that is gently, relentlessly, and quietly stretching the very fabric of reality itself. This is the story of dark energy. Let's begin by creating a shared space of tranquility, a mental sanctuary where we can mute the incessant hum of the everyday world. Imagine the noise fading, the obligations loosening their grip, allowing your mind to become a calm, clear vessel, ready for a different kind of journey. Tonight, we drift together, not across oceans, but across the cosmos, toward a mystery so fundamental it redefines our understanding of existence. We are venturing into the realm of dark energy, the invisible and dominant force that is quietly orchestrating the ultimate fate of our universe. This exploration is not a lecture filled with dense equations, but a meditation on wonder, a quiet contemplation of the grand cosmic ballet unfolding in the silent darkness above. As we prepare to float into the depths of space and time, take a moment to picture our fellow listeners. Imagine people scattered across continents, in different time zones, under different skies, some gazing at a dawn-lit horizon, others under a canopy of midnight stars. All of us, for this brief period, are united, pausing our individual lives to contemplate the same magnificent, shared mystery. We are a global community of wonder, connected by curiosity and the profound silence of space. When you step outside on a clear, dark night and gaze up at the star-scattered sky, it's easy to be lulled into a sense of perfect stillness. The cosmos can feel like a vast, unchanging cathedral of light, a static masterpiece painted on a black canvas. But this tranquility, this perceived permanence, is a profound illusion. In reality, our planet, our solar system, and our entire galaxy are hurtling through space at incredible speeds. And far beyond our galactic shores, distant galaxies are racing away from us, not because they are moving through space, but because the very fabric of space between everything is expanding with each passing moment. It's like baking a raisin loaf. As the dough rises, every raisin moves away from every other raisin, not because they are crawling through the dough, but because the dough itself is expanding. The story of dark energy begins not with a grand discovery, but with a simple, logical question that astronomers sought to answer for decades. Is the universe's expansion, a known fact since the observations of Edwin Hubble in the 1920s, slowing down? It was the only sensible question to ask. After all, the universe is filled with matter, stars, galaxies, gas, and dust, and matter exerts gravity. Gravity pulls things together. Therefore, the mutual gravitational attraction of everything in the cosmos should act as a cosmic brake, gradually slowing down the expansion that began with the Big Bang. To measure this expected deceleration, astronomers needed a reliable way to gauge immense distances across space and time. They needed a standard candle, an object of known, consistent brightness that could serve as a cosmic lighthouse. They found it in a specific type of stellar explosion, the type Ia supernova. These cataclysmic events occur when a white dwarf star in a binary system siphons off matter from its companion until it reaches a critical mass and explodes. Because they all detonate at roughly the same mass, their intrinsic brightness is remarkably consistent. By finding these supernovae in distant galaxies and measuring how dim they appeared, astronomers could confidently calculate how far away they were, and by measuring their light's redshift, they could determine how fast they were receding. The stage was set in the late 1990s. Two independent teams of scientists, the Supernova Cosmology Project and the High Z Supernova Search Team, were engaged in a friendly but intense rivalry, both using powerful telescopes to hunt for these distant type Ia supernovae. Their goal was the same: to measure the universe's deceleration, and in doing so, to determine the ultimate fate of the cosmos. They pointed their instruments to the deepest, darkest patches of the sky, patiently collecting the faint light from galaxies billions of light-years away. As the data trickled in and they began to plot their findings, a baffling and deeply unsettling picture emerged. The most distant supernova, the ancient lighthouses from the dawn of time, were consistently dimmer than they should have been. Think about what that means. If a streetlight of a known wattage looks dimmer than you expect, it can only mean one thing: it's farther away than you thought. The supernovae were farther away than all prevailing theories of cosmology predicted. This wasn't a small discrepancy. It was a significant, undeniable deviation. The initial reaction was one of disbelief. The scientists spent months consumed by self-doubt, meticulously checking their data, recalibrating their instruments, and searching for any possible error or alternative explanation. Had they miscalculated the obscuring effects of cosmic dust? Was there some unknown evolutionary effect where ancient supernovae were simply different from their modern counterparts? Every alternative was investigated and systematically ruled out. Finally, they were forced to confront an impossible, logic-defying truth. The only way for the supernovae to be that far away was if the expansion of the universe over the last 5 to 6 billion years hadn't been slowing down at all. It was speeding up. This discovery, announced in 1998, sent a shockwave through the scientific world. It was as if you had thrown a set of keys into the air and watched them accelerate upwards into the sky instead of falling back down. An unknown force, an anti-gravity pressure woven into the fabric of space itself, was overpowering the collective gravity of all the matter in the universe and pushing everything apart at an ever-increasing rate. Cosmologist Michael Turner coined a name for this mysterious entity: dark energy. In a single, stunning stroke, our understanding of the cosmos was fundamentally overturned. The revelation was twofold. First, the universe's fate was not a gentle slowdown or a fiery collapse, but an endless, accelerating expansion. Second, it forced a humbling cosmic inventory check. The calculations revealed that all the stars, planets, galaxies, and gas clouds we can see, everything made of ordinary matter, make up less than 5% of what truly exists. The rest is a dark, invisible realm composed of about 25–27% dark matter and a staggering 68–70% dark energy. We are, it turns out, living in a universe where the familiar is just a tiny sliver of the whole. So, what is this dark energy? When we ask this question, we step from the solid ground of observation into a realm of profound theoretical mystery. We have given a name to our ignorance, but we have not yet grasped the nature of the thing itself. The leading theory, and the simplest explanation, is that dark energy may be an intrinsic property of space itself. It's an inherent energy of the vacuum, a concept Albert Einstein first proposed in a different context. This idea, known as the cosmological constant, suggests that even in a perfect vacuum, devoid of all matter and radiation, there is a baseline level of energy. This vacuum energy doesn't dilute as space expands. On the contrary, as the expansion creates more space, more of this energy comes into being, creating more repulsive pressure and pushing the expansion ever faster. This concept finds a strange echo in the bizarre world of quantum mechanics, which predicts that empty space isn't empty at all. It's a roiling, effervescent sea of virtual particles that pop into and out of existence in fleeting moments. This constant dance of particles could, in theory, imbue the vacuum with the very energy we call dark energy. However, this beautiful convergence of cosmology and quantum physics leads directly to what has been called the greatest puzzle in the history of physics: the cosmological constant problem. When physicists try to use quantum theory to calculate how much of this vacuum energy should exist, the answer they get is catastrophically, monumentally wrong. The predicted value is about 10 to the power of 120 times larger than the value we actually observe. That's a 1 followed by 120 zeros. To put this discrepancy into perspective, imagine measuring the size of a single atom and having your prediction be off by the size of the entire observable universe. This isn't just a small error. It's a fundamental breakdown in our understanding of how the universe works at its most basic levels. It's a colossal clue telling us that we are missing something profound, something essential about the nature of reality. This vast chasm between theory and observation is one of the most exciting and humbling frontiers in all of science. Beyond the deep mystery of what dark energy is, there lies the equally compelling question of what it will do. Its behavior is not just an academic curiosity. It is the force that will write the ultimate future of everything. The fate of the cosmos is locked in the nature of this invisible energy. If dark energy remains a true cosmological constant, unchanging and persistent, then the universe is destined for a future known as the Big Freeze, or heat death. In this scenario, the accelerating expansion will continue forever. Galaxies will drift farther and farther apart until they cross a cosmic horizon, their light no longer able to reach us. The night sky of the far future will be a dark, lonely, and empty place, with our own Milky Way galaxy an isolated island in an ever-expanding, silent ocean of blackness. Eventually, over trillions of years, the stars themselves will burn out, and the universe will cool to a near-uniform temperature of absolute zero, devoid of heat, life, and motion. However, some theories suggest that dark energy might not be constant. It could be a dynamic field, something cosmologists have nicknamed quintessence, that could change over time. If this field were to weaken gravity, might one day regain the upper hand, halting the expansion and pulling the universe back together in a fiery, cataclysmic Big Crunch, a reverse of the Big Bang where everything collapses into a single point. Or, in a more terrifying possibility, the dark energy could grow stronger over time. This hypothetical form, known as phantom energy, would lead to a dramatic and violent end called the Big Rip. In this scenario, the accelerating expansion would become so powerful that it would overcome all the other forces of nature. First, it would tear apart galaxy clusters, then the galaxies themselves. As the end neared, the repulsive force would become strong enough to overcome the electromagnetic forces holding stars and planets together. In the final fraction of a second, it would become so overwhelmingly powerful that it would tear apart atoms and subatomic particles themselves, ripping the very fabric of reality to shreds. These distant speculative fates serve as a powerful reminder that we are not living in a static moment, but are part of a grand, evolving story, a cosmic narrative on a truly unimaginable scale. Perhaps the strangest and most profound thing about living in a universe so thoroughly dominated by dark energy is that our daily lives feel completely normal. It is an incredibly gentle giant. Dark energy is a force that operates only on the grandest of cosmic scales, exerting its influence over the vast empty gulfs between galaxy clusters. It has absolutely no noticeable effect on your coffee cup, the orbit of the Earth around the Sun, or even the structure of our Milky Way galaxy. Within these systems, gravity is still the undisputed king, easily overpowering the subtle push of dark energy. We are like microscopic creatures living on the surface of a slowly inflating balloon, completely unaware of the expansion that carries us along. We can't feel it. We can't touch it. We can only infer its existence by looking outward, by observing how it stretches the very light that travels across the cosmos from distant galaxies. As light journeys through expanding space for billions of years, its waves get stretched out, shifting its color toward the red end of the spectrum in a process known as cosmological redshift. This redshift is a cosmic record, a fossilized imprint of space expanding over eons. The more distant a galaxy is, the longer its light has traveled through expanding space, and the more redshifted it becomes. It was by measuring the precise relationship between distance and redshift that astronomers first uncovered this cosmic acceleration, proving that the balloon of our universe is inflating at an ever-increasing rate. Dark energy doesn't just expand the universe, it sculpts it. The amount of this force appears to be remarkably, perhaps even suspiciously, balanced. If dark energy were significantly stronger, its repulsive force would have been so powerful in the early universe that it would have ripped the primordial gas clouds apart before they could ever collapse to form the first stars and galaxies. The universe would be a thin, cold, and lifeless soup of scattered particles. On the other hand, if dark energy were much weaker or non-existent, gravity would have been the unopposed dominant force. The initial expansion from the Big Bang would have quickly reversed, and the entire universe would have collapsed back in on itself in a big crunch long before life, or even planets, had a chance to form. Our existence hinges on this delicate cosmic balance. This remarkable fine-tuning has led to a deep puzzle known as the cosmic coincidence problem. Why is dark energy's influence becoming dominant in the universe right now? For the first 9 billion years of cosmic history, matter and its attractive gravity were in charge. Now, in our cosmic epoch, dark energy has taken over. Why now? At the very point in cosmic history when life and consciousness have emerged to observe it. Is it just a random fluke? This question pushes us to the very boundaries of science and into the realm of philosophy. It gives rise to ideas like the anthropic principle, which suggests that the universe's properties must be compatible with the existence of observers like us, because otherwise, we wouldn't be here to observe them. Perhaps we exist in just one pocket of a vast multiverse, a cosmic foam of countless other universes, each with different physical laws and amounts of dark energy. In most of those universes, the conditions are hostile to life, but with an infinite number of universes, it's not surprising that a few, like ours, would have the perfect recipe for stars, planets, and conscious beings. The discovery of dark energy serves as a profound and necessary lesson in cosmic humility. It's a stark reminder of the severe limits of human intuition. The universe operates by a set of rules that are far stranger and more counterintuitive than our everyday experience on this tiny planet would ever lead us to believe. And yet, through the power of the scientific method, through careful observation, rigorous testing, and a willingness to follow the evidence wherever it leads, we have managed to catch a glimpse of these bizarre cosmic laws. Perhaps the most remarkable realization of all is that we are living in a uniquely privileged moment in cosmic history. We exist in a perfect epoch to be cosmic archaeologists. The universe is now old enough for stars to have forged heavy elements, for planets to have formed, and for life to have evolved. But it's also still young enough that we can look out and see the evidence of our origins. We can still detect the faint afterglow radiation of the Big Bang, and we can still see the light from distant galaxies before they are pushed beyond our cosmic horizon by the accelerating expansion. Imagine astronomers in the far distant future, living in a galaxy that has become an isolated island in an endless void. The light from all other galaxies will have redshifted into oblivion, stretched beyond the point of detection. The cosmic microwave background radiation will have diluted to almost nothing. For those future scientists, the universe might appear static and empty. They might have no way of knowing there was ever a Big Bang, that other galaxies ever existed, or that the universe was expanding. The fundamental clues to our cosmic story will have been erased by dark energy. We are living in a fleeting window of clarity, a precious and perhaps unrepeatable moment to piece together the grand narrative of the cosmos. The story of dark energy contains a beautiful and poignant irony, one that leads us directly back to a concept that its creator, Albert Einstein, once famously called his greatest blunder. In 1917, When Einstein applied his new theory of general relativity to the entire universe, his equations told him that the cosmos must be dynamic. It must either be expanding or contracting. However, the prevailing scientific view at the time was that the universe was static and eternal. To make his theory fit the facts, as they were then understood, he introduced a mathematical fudge factor, a term he called the cosmological constant, to counteract gravity and hold the universe in a perfect static balance. When Edwin Hubble later provided observational evidence that the universe was, in fact, expanding, Einstein quickly abandoned the idea, lamenting that he had marred the elegance of his original theory. Yet decades later, this discarded idea, this blunder, has been resurrected and now stands as our best and simplest explanation for an accelerating universe. If dark energy is indeed this cosmological constant, it possesses a bizarre and unique quality, unlike any other form of energy we know. As the volume of space expands, the density of matter and radiation within it decreases. They get diluted. But the energy density of the cosmological constant remains the same. This means that as space expands, more and more of this energy is constantly being created, seemingly from nothing. It is an inherent property of space-time itself. In a sense, the universe provides its own fuel for expansion. It's like a bank account that pays interest not on the principal, but on the total volume of the bank, a kind of cosmic free lunch that funds its own relentless growth in an account that can never be overdrawn. As we look out into the universe today, we see a magnificent cosmic web. Galaxies are not scattered randomly. They are arranged in vast, interconnected filaments surrounding immense, empty voids. Gravity has been the master architect for billions of years, pulling matter together to form the vast chains of galaxies, clusters, and superclusters we observe. For most of cosmic history, gravity was winning the cosmic tug-of-war, pulling matter into ever larger structures. But we are living through a profound and fundamental transition. We are witnessing the end of the age of structure formation in the universe. Dark energy's relentless, repulsive push is now overpowering gravity's pull on the largest scales. The great clusters and superclusters we see today may very well be the last such massive structures that will ever form. The cosmic web is being stretched and pulled apart. From this point forward, the universe will become a place of increasing isolation. Dark energy will continue to push each galaxy cluster away from every other, turning them into lonely, gravitationally bound islands adrift in an ever-expanding cosmic ocean. We are uniquely positioned in time to see both the glorious legacy of the gravity-dominated past and the dawn of a new, isolating future, ruled by the quiet, persistent push of dark energy. Perhaps the most remarkable quality of dark energy is its sheer hiddenness. Unlike gravity, electromagnetism, or the nuclear forces, which operate with tangible and often dramatic effects, dark energy works with a profound and pervasive quietness. It shapes the ultimate destiny of the cosmos without ever drawing attention to itself in our local environment. There is no dark energy particle to be found, no field to be directly measured. Its existence is revealed only through its subtle, large-scale effect on the geometry of space-time. This gives it an almost philosophical or spiritual quality, a sense of a deep, significant, and invisible presence, lying just beneath the surface of perceived reality. It reveals a universe that is far more interconnected and mysterious than we ever imagined. In one of the most mind-bending concepts in modern physics, the mathematics describing the fleeting quantum fluctuations in the smallest possible pockets of a vacuum are somehow inextricably tied to the acceleration of the entire cosmos. Dark energy forms a bridge between the microscopic world of virtual particles and the magnificent, grand-scale evolution of the universe, linking the infinitesimal with the infinite in a way we are only just beginning to comprehend. The search to understand the nature of dark energy is not the work of a lone genius in an isolated lab. It has become a truly global human endeavor uniting thousands of scientists from dozens of countries in a shared and peaceful pursuit of cosmic knowledge. Massive international collaborations, such as the Dark Energy Survey and the recently launched Euclid Space Telescope, represent humanity at its collaborative best. These projects bring together experts from diverse backgrounds and cultures, all focused on a single, transcendent goal. In a world so often fractured by division and conflict, this shared quest offers a powerful and inspiring glimpse of what our species can achieve when we focus on our shared curiosity rather than our differences. Using some of the most advanced instruments ever built and supercomputers processing staggering amounts of data, we are acting as cosmic detectives. We are gathering faint clues written in ancient starlight, analyzing the subtle distortions in the shapes of distant galaxies, and mapping the large-scale structure of the universe. We are slowly, patiently, and collectively building a case, piecing together the evidence from across billions of years of space and time to uncover how the universe truly works. For all our incredible technology, our global collaboration, and our brilliant theoretical minds, dark energy continues to guard its most essential secret. We know it's there, we can measure its effects, but we still don't know what it is. This persistent and humbling mystery has a powerful effect on the scientific community, and on all of us. It teaches us a kind of cosmic patience, a deep respect for the complexity of the universe. The cosmos, it seems, is under no obligation whatsoever to make sense according to our limited human expectations or to conform to our neat and tidy theories. In this, dark energy invites us to do something that can be difficult in our modern, answer-driven world: to embrace the mystery itself. It encourages us to see the state of not knowing not as a failure, but as a beautiful and natural part of the human experience. It reminds us that the journey of discovery, the process filled with awe, wonder, and the thrill of the chase, is just as important, and perhaps even more meaningful, than arriving at a final destination. Dark energy challenges us to remain open, to expand our conception of what is possible, and to find wisdom in the vastness of our own ignorance. While the cosmological constant, the idea of a static, unchanging dark energy, is the simplest explanation, it is by no means the only one. The possibility that dark energy is not constant, but is instead evolving, is a concept that keeps cosmologists captivated and is at the forefront of modern research. Some recent, though still tentative, observations have hinted that the strength of dark energy may have varied over cosmic time. This has led to the development of exotic and fascinating new theories. One is quintessence, which proposes that dark energy is a dynamic field that changes in space and time, much like an electromagnetic field. Its energy could be slowly rolling down a potential, causing the cosmic acceleration to change over eons. Another, more radical idea is phantom energy, a form of dark energy that actually grows stronger over time. As mentioned earlier, this would lead to the Big Rip scenario, where the repulsive force of dark energy eventually becomes infinite, tearing apart the very fabric of space-time. These speculative but mathematically plausible ideas remind us that the universe is not a static machine with a predetermined outcome. It may be a living, evolving system, and its ultimate fate is a story that is still being written, with the final chapter yet to be revealed. To probe this evolving mystery and to choose between the competing theories of the cosmos's future, we are building the most ambitious and powerful time machines in the history of science. These are not devices that transport us through time, but telescopes so powerful they allow us to look back in time by capturing the ancient light from the early universe. The Euclid Space Telescope, a mission by the European Space Agency with NASA collaboration, is currently mapping the shapes and positions of billions of galaxies over a vast swath of the sky. It's looking for the tiny, subtle distortions in galaxy shapes caused by dark matter, and the way dark energy has warped the geometry of space over cosmic history. On the ground, The Vera C. Rubin Observatory in Chile is poised to create a revolutionary, decade-long movie of the southern night sky. By repeatedly surveying the same patch of sky, it will discover millions of new supernovae and track the expansion of the universe with unprecedented detail and precision. And looking ahead, NASA's Nancy Grace Roman Space Telescope will use its wide-field infrared vision to peer even deeper into the past, back to a time when the universe was young. One of its key goals is to literally watch the moment in cosmic history when dark energy began to assert its dominance over gravity, to observe the cosmic transition from a decelerating to an accelerating cosmos firsthand. These magnificent instruments are our eyes on the universe's past, and they hold the key to understanding its future. This grand cosmic exploration ultimately leads us to a beautiful and profound paradox. The same fundamental laws of physics and the same basic material ingredients connect everything in the universe, from the quantum foam that underlies reality to the vast expanding cosmos and, incredibly, to us. The carbon in our bodies, the iron in our blood, the calcium in our bones, every heavy element that makes life possible, was forged in the fiery hearts of long-dead stars and scattered across the galaxy in supernova explosions. We are, in the most literal sense, stardust. We are held together by the very same forces that sculpt the galaxies. In this deeply interconnected view of the cosmos, the emergence of human consciousness can be seen as something truly extraordinary. It is the universe becoming aware of itself. We are a temporary, intricate, and fragile arrangement of cosmic matter that has somehow, against all odds, evolved the capacity to look back, to question, to understand, and to contemplate its own origins, its own future, and its own deepest and most elusive mysteries. Our curiosity is the universe's curiosity. Our search for answers is the cosmos striving for self-knowledge. The discovery of dark energy did not happen with a sudden eureka moment or a dramatic explosion in a lab. It unfolded like a quiet, patient detective novel with the clues scattered across the cosmos. Its existence was revealed not through a loud shout, but through the faintest of whispers, meticulously pieced together by dedicated astronomers studying the faint, time-stretched light of stars that died billions of years ago. This journey of discovery has fundamentally changed our perspective on reality itself. We once looked at the vast emptiness between the galaxies and assumed it was simply nothing, a void. Now we are beginning to understand that this vacuum, this apparent nothingness, may in fact be the most powerful and influential something in the entire cosmos. It is the engine driving the universe's expansion and the force that will determine its ultimate destiny. The biggest mystery of all was hiding in plain sight, in the silent, empty spaces we had always taken for granted. The revelation of dark energy and dark matter continues a long and important scientific tradition of cosmic humility. It is the latest in a series of great demotions that have progressively shifted our perspective on our place in the universe. We once believed that the Earth was the center of everything, only to learn from Copernicus that we orbit a rather ordinary star. We then learned that our Sun is but one of billions of stars in the Milky Way galaxy, and then that our galaxy is but one of hundreds of billions in the observable universe. Now, we are confronted with an even more profound reality check. We have learned that everything we can see and touch, all the ordinary baryonic matter of our world and the heavens, constitutes less than 5% of what is truly out there. We are a tiny fraction of a cosmic whole dominated by vast, invisible, and mysterious forces. But this realization does not make us insignificant. On the contrary, it makes our existence seem all the more precious, all the more extraordinary. We are a rare, complex, and conscious flowering in a universe composed almost entirely of forces we are only just beginning to name. Perhaps the most beautiful and inspiring thing that this grand cosmic mystery reveals is not about the universe, but about ourselves and our own human nature. Despite our fleeting lives on this small planet, We possess a boundless and insatiable curiosity. It is a curiosity so powerful that it drives us to build magnificent instruments, to create global collaborations, and to dedicate our lives to understanding forces that dwarf us in every conceivable way. The international, multi-generational quest to comprehend dark energy is a testament to humanity at its absolute best. It is a massive communal effort, united not by profit, necessity, or conflict, but by a shared and profound sense of wonder at the cosmos we are privileged to call home. It speaks to a deep need within us to understand our place in the grand story, to know where we came from and where we are going. It is the purest expression of the exploratory spirit that defines our species. The persistent, unresolved mystery of dark energy is doing more than just challenging our cosmological models. It is pushing the very boundaries of science to its philosophical frontiers. When confronted with something so fundamentally strange, something that defies our most basic intuitions about energy and space, we are forced to consider ideas that once seemed to belong only to the realm of science fiction. Are there extra dimensions of space that we cannot perceive, whose properties influence the universe we can? Does the strange link between the observer and the observed in quantum mechanics have implications on a cosmic scale? Is it possible that our entire scientific method, so successful for centuries, is incomplete and that a new kind of science is needed to make the next great leap? Dark energy acts as a cosmic catalyst, forcing us to question our deepest assumptions about the nature of existence itself. It may be heralding the next great conceptual revolution in our understanding of reality, a paradigm shift as profound as those initiated by Newton or Einstein. The story of the discovery of the accelerating universe is, above all, a testament to the integrity and power of the scientific process. It began with Hubble's observation of an expanding universe, which led scientists to a logical and reasonable goal: to measure the expected slowdown caused by gravity. But the evidence they found pointed in the exact opposite direction. The conclusion was so startling, so contrary to all expectations, that the research teams initially assumed they had made a terrible mistake. Their greatness lies not just in their meticulous work, but in their intellectual courage. It was their willingness to follow the data, to listen to what the universe was telling them, even when it contradicted everything they thought they knew, that led to this revolutionary discovery. This represents the very heart of science. Not in confirming what we already believe, but in having the courage and the readiness to let the universe surprise us, to accept that its truths may be far stranger and more wonderful than our limited imaginations can conjure. The discovery of dark energy has fundamentally rewritten our cosmic inventory. It has pulled back a curtain to reveal a universe far more mysterious than we ever knew. Before 1998, we thought the story of the cosmos was a grand battle between the outward momentum of the Big Bang and the inward pull of gravity from all the matter we could see. Now we know that everything we have ever observed in the heavens, every star, every nebula, every galaxy, is just a tiny, almost negligible fraction of what is actually out there. We have learned that we inhabit a universe where the vast majority of reality is composed of two invisible components: dark matter, the mysterious substance whose gravity holds the galaxies together, and the even more enigmatic dark energy, the force whose anti-gravity is pushing them apart. It is a humbling and profoundly awe-inspiring realization. The destiny of everything we can see, the fate of all the light and matter in the cosmos, is being shaped and driven by forces that we cannot see, forces whose fundamental nature remains one of the greatest unsolved mysteries of our time. As you rest here tonight, on the verge of sleep, you are an active participant in this grand cosmic adventure. You do not need a billion-dollar telescope or a degree in astrophysics to be a part of this story. Your innate capacity for wonder, your simple ability to pause and contemplate these immense mysteries, connects you directly to the heart of this great human endeavor. The very same invisible force that is pushing distant galaxies apart is flowing silently and harmlessly through the very space you occupy. In a very real sense, through your consciousness, the universe is becoming aware of its own deepest secrets. Through your curiosity, the relentless cosmic acceleration achieves a fleeting but profound moment of self-reflection. You are not just an observer of this story, you are a part of it. You are the means by which the cosmos contemplates itself. When you wake in the morning, you will return to a world that is imperceptibly, infinitesimally larger than it was when you fell asleep. The silent work of dark energy never ceases. Having contemplated this profound mystery tonight, perhaps you will carry with you a deeper appreciation for the hidden wonders and unseen forces that shape the reality that surrounds us. Future generations of scientists may one day solve this puzzle, but we have been uniquely privileged to live at the moment of its stunning revelation. In this quiet space between sleeping and waking, you exist as a conscious witness to a magnificent, beautiful, and endlessly expanding cosmos. You are a temporary and precious gathering of stardust that has somehow learned to contemplate infinity. The journey into the heart of dark energy reveals a universe far stranger and more magnificent than we ever imagined. It teaches us that the greatest discoveries often begin with the courage to question our most basic assumptions. It shows us that even in an age of incredible knowledge, we are still surrounded by profound mystery. And most importantly, it reminds us that our ability to wonder is one of the most powerful forces we possess. It connects us to each other and to the cosmos itself. What does the existence of this vast, invisible reality mean to you? How does it change your perspective on your own life and our collective place in the universe? Thank you for joining me on this journey tonight. I wish you deep rest and dreams filled with cosmic wonder. May your health be as constant and reliable as the laws that govern the stars. If you enjoyed this exploration, please consider subscribing to the channel for more journeys into the heart of science and mystery.